The next thing we'll talk about is the certainty equivalent rate. And we're going to define the certainty equivalent rate as a rate you can earn, something you can earn with certainty. In other words, it's a risk-free rate. It's a slightly awkward way to say this. But it is the risk-free rate that is equivalent in utility to a risky asset. And it lies at zero risk on our curve, which is the point at which the parabola intersects the y-axis. So note that the certainty equivalent rate is something we calculate for comparison purposes. It's not a rate that is available. It's not in the investment opportunity set. You can't invest in a certain certainty equivalent rate, but we can compare the certainty equivalent rate to an actual available risk-free rate, which we'll do in a minute. So how do we calculate this? Well, we calculate the certainty equivalent rate for a person with A equals 2 that invests in asset X. And here's what we're looking for. We're looking for the risk-free rate that, if it were available, would have the exact same utility for this investor as asset X. And so how do we measure risk, the risk-free rate? Well, we set the sigma equal to 0. So what risk-free rate produces the same utility as asset X for an investor with A equal 2? Well, it's pretty simple. We're just going to figure out what the utility that they earn, so that's the expected return, minus A sigma 2 squared, divided by 2, so that's the 0.1, 0.2, we plug that in, and we get that this person earns utility of 0.006. Next, we calculate what the return must be for a zero risk asset that has equivalent utility. And so if I'm going to plug in 0, but have a utility of 0.06, we can see fairly trivially that the expected return is also 0.06. So the certainty equivalent rate is 6% for a person with A equals 2 that invests in asset X. This person would be indifferent between investing in asset X and earning 10% with 20% risk and earning risk-free 6%. And we can see that this lies on this same curve. And so the next thing we can do is we can compute the certainty equivalent rates for assets I and assets J for an investor with A equal 2. And recall that asset I has an expected return of 13 and a risk of 35. J has an expected return of 8 and a risk of 12. And so for asset I can calculate the utility for this person. They have a utility of 0.0075, and it turns out that this is also the certainty equivalent rate. So the certainty equivalent rate for this person is 0.0075. And for asset J, the certainty equivalent rate is 6.56%. And so here I can draw the isoutility curves for an investor with A equals 2 through asset J. It intersects the y-axis at 6.56%. For asset X, it intercepts at 6.00%. And for asset I, it intersects at 0.75%. And so we can find the certainty equivalent rates. This helps us plot the isoutility curves for an investor with A equals 2. We know that the isoutility curve for asset J and A equals 2 is a parabola-shaped curve that passes through J and intersects 5.65 on the y-axis. We know that for asset X and A equals 2, it's going to intersect this point and 6%. And for asset I, it's going to intersect this point and 0.0075. It's also useful because the next step to develop our asset allocation model is to choose between a risky asset and a given available risk-free asset. In other words, your asset choice, your portfolio choice, is now 100% of your wealth in the risk-free or 100% of your wealth in the risky asset. So how do we choose these investments? Well, we compare utilities. So now we're going to assume a two-asset universe. We can either invest in asset X, which has an expected return of 10 and a risk of 20, or we can put all our money in a risk-free investment that earns 3%. Well, which is better? Well, it depends on the person. So let's try this with two people. Let's have someone who has a risk aversion of 2, A equals 2, and we can see that this person has the utility that they earn from investing in the risky asset is 0.06, and the utility they earn investing in the risk-free asset, well, this is relatively simple because I'm going to plug in 3 for expected return and 0 for risk, and I'm going to get 0.03. And so the person who has a risk aversion level of 2 would prefer the risky asset. If they have a risk aversion level of 4, well, how much utility did they derive from investing in the risky asset? Well, now I'm going to multiply the variance, half the variance, by 4 instead of 2. This is going to lower the overall utility for this person. And so I can see for a person with risk aversion of 4, they only derive a utility level of 2 from the risky asset. Again, they derive the same utility of 3 from the risk-free, and so they prefer the risk-free asset. And so again, to reiterate, the person with a greater level of risk aversion prefers the risk-free asset. The person with a lower level of risk aversion prefers the risky asset. And in the curve below, we can see I've drawn the ISO utility curves going through asset X. For A equals 4, it's a steeper curve, and I can see that this intersects the expected return y-axis at 2. And for a person with A equals 2, asset X has an equivalent, a certainty equivalent rate or a risk-free rate that has equivalent utility of 6%. And since 3 is available, since X is equivalent to 6 and 6 is better than 3, this person prefers X. But for this person, since X is equivalent to 2 and 3 is available, this person prefers the risk-free. And because these are theoretical curves, instead of drawing them this way through asset X, I can actually draw them through the risk-free. Since iso-utility curves are theoretical, we can also draw them both running through the available risk-free rate. And again, A equals 4 is steeper than A equals 2. And again, I've added a blue line, a blue dot, and a red dot. And so the person with A equals 2, the blue dot is equivalent to the 3% rate. But since X dominates the blue dot, for this person, X is better than the risk-free. And for a person with A equals 4, the red dot is equivalent to the 3% risk-free. And obviously the red dot dominates X, and so therefore the 3% dominates asset X. And so just to recap, we now know how to choose between any two assets, any two risky assets, a risky asset and the risk-free. We choose the asset that has the higher utility. The next step is an investment universe that consists of a risk-free asset and a single risky asset. But now we're going to allow the investor to choose any allocation between these two. So you can be 100% in the risk-free and 0% in the risky, or you can be 99 and 1 or 98 and 2. Now you can allocate any way in between these two assets. So what does this allocation set look like? What does the allocation between two assets, one that's risky and one risk-free, what does your opportunity set look like? And then how should you allocate? What allocation between these two assets should you choose? But first, we have to do a bunch of math.